Hey guys, so following the questions in the forum, I will post a very small video on reciprocal lattice and how to generate one. Okay, so before we begin on this route, let us take an example of an unit cell and just go about doing this. Okay, so let us take a simple cube, right? It has side A everywhere, right, and atoms at each corner. How many atoms per unit cell does it have? Be 1, right? How? So there are 4 atoms in this phase and 4 atoms in the opposite phase, and so basically there are 8 atoms. However, these 8 atoms are shared between 8 such unit cells, because you can think about this atom being shared by this unit cell here, right, and 2 more on the top, similarly 2 more here, right? So basically this unit cell has 1 2 3 4 and 1 2 3 4 8. So totally we have 8 into 1 by 8, making 1 atom per unit cell. If we take an example of a BCC, we have an atom at the center of the body. Now this will have similarly 8 at the edges, and you have 1 at the center. So a BCC will have 2 atoms per unit cell. Now let us first address the BCC first and then go on to the FCC later on. So this atom at the body center can be described as basically, let us call this A vector is A by 2 x plus y plus z, right? You take half the lattice step in each direction, you will get this atom, right? Now till now we have talked about an unit cell which is a cube with an atom at the center, and this is called an unit cell, or it is called as a conventional unit cell, where the number of atoms per unit cell is more than 1. However, you can also define what is called as primitive unit cell, which has only 1 atom per unit cell. In the lecture that I have posted before on the reciprocal lattice, I have said that the unit cell does not have to be unique. So there can be several such unit cells. You can use a BCC, which is a cube with atom at the center, or you can use a primitive unit cell which has 1 atom per unit cell. So the lattice vectors for a primitive unit cell actually comes from this vector at the center here, right? You have another atom in the body center here, so the vector goes like this, and then you have another one here, right? So the primitive vectors for a BCC will be like this. If we calculate the volume of the unit cell, which will be A dot B cross C, you can see that it will turn out to be A cube by 2. Now the original cubic volume is A cube, right, and it has 2 atoms, and the primitive unit cell has a volume A cube by 2. You can easily see that it has exactly half the volume of the original unit cell, right, conventional unit cell, which makes sense. Right? Now let's go to an FCC. Right, you have 4 atoms in the 4 corners, right? So basically it is 8 into 1 by 8, giving you 1 atom. In addition to that, each of the phase has 1 atom, right? So it has 6 phases, and each phase is shared by 2 unit cells. So basically you have number of atoms is 4 in the conventional unit cell, which is a cube. However, when we calculate the primitive unit cell, you can see that it should have a volume which is a cube by 4, right? Because it should have only one atom per unit cell, and the volume should be 1/4 to have one atom per unit cell kind of a relationship, right? So to do this, the unit vectors are chosen this way. So there is an cube, there is a atom here, there is an atom at the center of this guy, right? So a vector is a by 2 x vector plus y, b will be a by 2 y plus z c a by 2 z plus x. Now I will put it as an exercise for you to do a dot b cross c, and you can easily show it to be a cube by 4. Now to actually calculate the reciprocal lattice, one should find the primitive unit cell first, and then so the steps for reciprocal lattice will be first to find the primitive lattice, and to use the formula that we discussed in the lecture, right? So if you want to, so the question in the homework was to find the reciprocal lattice for silicon. So the silicon is basically an FCC, but it's a bit more than FCC, right? It's an FCC with a motif. So what we mean is an FCC is like this. Now the motif, let us, I'm going to write in a red, is you have an atom. For each atom there is a twin which is offset by 1/4 plus x plus 1/4 y plus 1/4 z, right? This is a silicon atom, but for all our for the reciprocal lattice calculation, we don't take this into account, and we just use an FCC because the underlying lattice is an FCC, right? So silicon number of atoms per unit cell is actually 8, because it's an FCC into 2, right? 2 atoms each. At each FCC lattice point there are 2 atoms, and FCC has 4 lattice points per unit cell. So silicon has 8 atoms per unit cell, and this unit cell is a conventional unit cell, right? And the primitive unit cell is actually a cube by 4, right? However, this remains same because this is based on just the number of lattice points and does not depend upon the number of atoms that it has, right? So your actual definition of a vector is still a by 2 x plus y, b is equal to a by 2 y plus z, c equal to a by 2 z plus x. Now the reciprocal lattice a is basically 2 pi into b cross c by a dot b cross c, right? So 2 pi b cross c, it will be a square by 4 y vector plus z vector cross z vector plus x vector divided by a cube by 8 x plus y dot y plus z cross z plus x. So how will we do this? This will come out to be 2 pi by a into 2. So x plus z plus into z plus x. How will we do this? Right? ijk 0 1 1 1 0 1. So this will turn out to be I plus j minus k divided by I plus j minus k dot x plus y, right? Which will give you another 2, which will be 2 pi by a I plus j minus k, right? This will be, you can do the same thing for B. This is capital A, right? Reciprocal lattice vectors. So you can see that, let us take the reciprocal lattice space. A vector is x, y and z minus 1, right? This looks as if it's an BCC, right, with a body center at the bottom, right? If you do this for A, B and C, you will see that the actual unit vectors are this way. I plus j plus k, C can turn out to be I minus j plus k, right? So the actual reciprocal lattice for a silicon, which is an FCC, is an BCC, right? With each of these is actually 2 pi by a, right? I mean to say is 2 pi by a. I'll stop here.